certain parameters. So in the condition space, what will be the condition? We have seen that two things we do consider. One is the temperature, one is the relative humidity. And temperature, what is the temperature we do maintain? That is the dry bulb temperature. And relative humidity, we can find out, we have already seen from the psychometric chart. If you know the dry bulb and the wild bulb temperature, we can find out the relative humidity. So the inside condition, what we maintain in 26.7, it means it will maintain below that. 26.7 degrees centigrade is the dry bulb, and the wet bulb is 20 degrees centigrade, and it gives us 55% of relative humidity, which is within the comfort zone, or comfort zone is 40 to 70% of the relative humidity. This condition will be when this condition will be inside condition, when the outside condition is 32.3 degrees centigrade dry bulb and 28.9 degrees centigrade wet bulb and a 78% relative humidity. That is the fresh air condition, outside condition, and we are maintaining a control condition in our conditions space, that will be this condition. So now for as we know that the air is bad conductor of heat, it means we have seen in the heat exchanger uh, chapter that whenever we have a fluid which is a bad conductor of heat, it means we need to how we means how we design for that, so that the heat transfer rate is high. One way we can do, we are increasing the heat transfer area. How we can increase? By using the fins. So fins are the extended surface on the tube. So in this case also, air, since it is an air is getting giving the temperature or getting the temperature, we use the fin tube type heat exchanger. It means what will be, this is the tube, and there will be number of fins attached to this tube, so that the surface area is increased. So this is called extended surface area, and it will give a very good effect because all direction the heat will be transferred. Three direction it will be, heat will be transferred through the fins. So it increases the heat transfer coefficient or the efficiency of heat transfer. And this fin type steam heating coil we do use here. Uh, we maintain inside temperature, we maintain 21 degrees centigrade when the outside temperature is minus 20.5 degrees centigrade around. Some design you will see it is written minus 18 degrees centigrade. It can be. So it will be minus 18 to minus 20, or this range it will be outside temperature degree centigrade, and this heating coil should be able to maintain a temperature inside 21 degrees centigrade. And it is fin type, tube type, fin tube type heat exchanger we do use. So another thing, like when it is passing through this, there is another consideration we need to do, that is the rate of air change is provided. It means when you are supplying, there is a mass flow rate that has to be maintained. It means when it is passing through that, it means you need to calculate how much time it will take to pass through. Within that time, it has to be, heat transfer has to be taken. And some of the air we have seen that it is recirculated, so that we can save some energy. So that it is already a condition, we don't have to consume energy from for that. What energy we need to consume for the fresh air to be conditioned. But except the hospital, wheelhouse, etc. We have seen those spaces. We have the mechanical exhaust like toilet and all. Those are contaminated air. We don't want to recirculate into the system. That has to be taken out by the exhaust. So now there are So recirculated air, we have got the air, means the wire mesh breathes, that is the filter basically, and it is on the deck ceiling. From where it is taking the recirculation is coming to the suction side of the blower, and where it is located in the like alleyways. So you'll see there are recirculation duct. Those ducts is not supplying air to the conditioned space. It is taking the uh, conditioned air and it is recirculating. It is going to the suction side of the blower. Now, heating, it can be uh, automatic. It can be manual, it can be automatic. So there will be automatic means you have the air handling unit where you have the heating coil for an example, and then it is the steam heating. So there will be an inlet, there will be an outlet, and there will be a control valve because the flow will be controlled of the steam. So there will has to be a sensor. So this will be the sensor, and from there it goes to the controller, and this controller, you have a set point. You know that set point, suppose you keep 21 degree centigrade because it is heating. So 21 degrees centigrade you keep. So what will happen? Accordingly, it will check the deviation, what is the measured value and the set value. If there is any deviation, it means this deviation, depending on the deviation, it will give a signal to your diaphragm, final control element. This is called final control element. Accordingly, the mass flow rate will be adjusted so that how much mass flow of steam will be there to the heating coil. So accordingly, it will be adjusted. Now tell me, suppose we have 21 degree is the measured value and 21 degree is the set value. What do you think will be the position of this valve when air is flowing through this and it is going to the conditioned space? So what will be the position of the control valve in that condition? Our measured value is 21 and the set value also 21. Anybody wants to answer to this question? Is it clear, my question? Yeah, Melissa, tell me.
Okay, I think the valve will be fully open.
Okay. So anybody else wants to answer to this question? Melissa, I'll come back to you. Let me get other answer. Then I'll reply to your answer. So
Okay.
anybody? So okay, let us see this. If it is fully open, okay, Teka, just found, tell me.
Sir, I think it will remain open at the same position.
Okay. So anybody else? Teka, I'll come to your answer. Yeah, anybody else? Now let us see. Like Melas said that it will be fully open. Teka said it will remain at the same position. That is the right answer. It will be in open position, but it will remain at the same position. There will not be any change in position. But what do you think should be the position, best position? What I am saying that how much it will be in open position. What will be the percentage at which it should open when it is maintaining this temperature? Is the question is clear? What if you take the percentage? 0% is fully closed, 100% is fully open. So what will be the position? Yeah, that's fine. Tell me.
It will open 75%.
Okay, so let us come to this now. Like, if it is 50%, that is the best. Why it is so? If it is 50%, it is the best because suppose there is a variation. This variation, this temperature can be less than 21, more than 21 also. So if we think about it, so if you think about it, then if it is less than, it means if it is less than 21, it has to open. If it is more than, it has to close. Then if it is 50%, we have, suppose this is the fully open, this is fully closed, we are here. So we have this much we can adjust, lower side, closing side, this much we can adjust. So the flexibility is maximum. Now, like for an example, if it is fully open, in that condition, suppose the temperature has reduced to below 21 degrees centigrade. It won't be able to open further. So when it is maintaining that time, it should not be fully open or fully closed. It should be best position is 50%, but it might not be 50%. It can vary slightly up and down. So that will be the ideal position for having the maximum control in both ways. Lower the temperature, measured value is less, measured value is high. Is it clear, everybody? Understood? Melissa, have you understood why it should not be fully open? Melissa, have you got it?
Yes, Chief, but your voice was broken. Can you repeat one more time? Thank you.
Okay. So when we have maintaining 21 degree and measured value is 21, best position will be 50%. This is the 50%. This is the fully closed. It means this is the fully closed. This is fully open. If it is fully open at that position, suppose the temperature become, measured temperature become 20 degrees centigrade. Then what will happen? You need more steam, mass flow of steam to the coil, heating coil, but it is already fully open. It won't be able to adjust that. So best position will be 50% so that you can open this side 50%. And this is, we can close if it is temperature is increasing, we can close it. So that allowance we have to adjust. But if it is fully closed, you will be able to adjust. That is the reason 50% is the best position, but it might not be 50%, it may be 60%. Like take us at 75%. 75% will be at the higher side. So around 60 to 70% it may be. So that still we have even 75% also you have 25% still to adjust if the temperature is less. So that is the reason it when it is maintaining the temperature, measured value and the set value is same, that time it should not be in fully open or fully closed position. Is it clear, Melissa?
Yes, Chief, it's clear. Yes, thank you.
Okay, let us then see the next part. And this ducting, how it is done, it is the steel plates. It's been, the ducting is made of steel plates. And the heating operation, as we have seen, it can be automatic, it can be manual. Automatic, it means it will maintain the temperature, outlet temperature after the, it means the AHU, that is the air handling unit. So then we have the other component. So like we have the compressor. Compressor, there will be two compressor. One will be in running condition, another will be in standby condition. And this type of compressor, we have different type. We can have the reciprocating type, and V type we can have. It will have the higher capacity, and you can have a screw type compressor also. Both are in use in air conditioning plant. So, and it will be electric motor driven, and motor, any electric motor on board the ship which you install, it has to be marine type. because maritime require there are some requirement which has to comply so that it is certified for the marine use. Then only it can be installed on ship. And it is automatic starting and stopping. It can have, and the condenser type of condenser we do use the shell and tube type condenser. It means the heat exchanger, we have seen the shell and tube type heat exchanger. It is exactly the same type of heat exchanger which is used. And here in like refrigeration system, we have the uh, shell fluid here also is the refrigerant, and the tube fluid is water. So shell side we use the uh, refrigerant which is at high pressure, and the water fluid, I mean the tube fluid is the water which is passing. So let us start again because there was some that the internet went off. That is the reason. So the shell and tube type heat exchanger we do use, and shell fluid is the refrigerant which is at high pressure, and the your tube fluid is the water. Why it is so? Because here, if you see the pressure, which side can, like tube can withstand the higher pressure, or the shell can withstand the higher pressure? Which side, shell or the tube? Which who the higher pressure, which can withstand higher pressure? It is the tube can withstand the higher pressure because the diameter is less. But whereas here we are using the refrigerant, that is the shell fluid is the refrigerant. The reason is because we need to do the maintenance of the water side. And water side can be maintained easily in this because you remove the end cover and then you can clean the water side, the tube side. Whereas this type of heat exchanger, there is no thermal expansion. It means it is the tube plate is welded onto the or based onto the shell. It means we are not allowing any, both end is braced on the welded. So we are not actually allowing any thermal differential thermal expansion. So our material design should be such so that it should expand equally, so that it should not, it means there should be a minimum differential expansion between the shell and the tube nest, because as minimum as possible. And if no expansion, relative expansion, then there will not be any thermal stress because of the temperature difference. So it is kept as such a way. And the your evaporator coil, the condenser is evaporator coil is also, it is the tube type and the field types. As the air is passing through the evaporator, air is wet conductor of heat. We have seen the surface area has to be increased to get the higher efficiency of heat transfer or the higher rate of heat transfer. That's why the field type we use for the evaporator. Evaporator will be in battery. It means it will be both end. There will be, so there will be tubes from here. It will go and come back. So it will, there will be two header here. One is for the supply, one is the inlet, and one is the return line. This will be connected to the Like the inlet will be connected to the, it means after the expansion valve, and then it will go to the cooling coil, the evaporator coil, and then return line, it will come back to the your compressor. And this compressor refrigerating plant, it is automatic control. It means, what does it means? The load, it means suppose the temperature of the air is reduced. In that case, what will happen? Okay, so Petros has a question, why we allow the expansion of the condenser. Now, let us see this diagram. So this is one of the refrigeration, this air conditioning condenser for the cooling system. So in this case, for an example, this is the shell. Here the tubes are not shown. We can let us draw one tube. So suppose there is a tube and the number of tubes are there. Then what will happen? The tube will expand because of the temperature variation. Any temperature variation, there will be an expansion. And this shell also will expand. This is the shell which will expand, as well as the tube will also expand. Now, if there is a differential expansion, what do you mean by the differential expansion? This will expand, it will increase the length. Tube also will increase the length because of the expansion, or it will reduce because of the contract. But if the change of length is not equal for shell and tube, then there will be a differential expansion. And if there is a differential expansion, we will have to allow that expansion. If we don't allow that expansion, then what will happen? There will be a thermal stress. Because it is trying to expand, we are restricting to expand. It means there will be a strain, which can affect your material, and material can fail. So that is the reason the differential thermal expansion we need to allow. Now suppose due to the temperature increase or decrease, it can increase. If it is increasing expansion, it is decreasing contraction. Now in that case, what will happen? If there is a condition where the shell is expanding, suppose shell has expanded this much, tube also has expanded this much, exactly the same. Then we don't have to any provision to keep for the differential expansion. Then the differential expansion is zero because the expansion for the shell and the tube are same exactly. So if we can material design, if we can make where the thermal expansion due to the temperature or the contract, it will be, for an example, it is the high temperature has increased because thermal expansion for the tube and the shell is equal. If it is contract, it is equal. Then we don't have to keep the thermal expansion. In this case, we are not keeping the thermal expansion because we weld it. The moment you weld here, this tube plate is welded onto the shell. Then what will happen? We are not allowing any thermal expansion. If there is any differential thermal expansion, that will not be allowed to move because there is no relative movement between the tube plate and the your shell because we are welded. Rigidly it is fixed. So the reason for keeping that thermal expansion because of the differential expansion. Now, as I told you, the material design we keep such a way so that the thermal expansion is not there. Differential thermal expansion will be there, but differential thermal expansion will not be there. Then what will happen? Suppose on the base we have a bolt which is securing. That bolt will have a hole. That hole on one end we keep it open. Then what will happen? It can take that thermal expansion and it will be total thermal expansion. That is not the differential. It means both will expand slightly because we keep the material design such that the thermal expansion is minimal. We can use certain allowance to make that allowing. Petros, is it clear to you why the
Yes, Chief, it's clear.
yeah.
Okay, thank you.
So this compressor we can have the automatic control. What does it mean? Suppose we have the AHU, that is air handling unit. So in outlet to the air handling unit, we have a thermostat which is measuring the temperature, and we have a set value. We know how much to maintain, and what we do if it is reached to that point, that temperature. We do compressor usually the uh, air conditioning compressor that is continuously running because it is a load is very high capacity compressor load is very high, so we avoid its cutting in and cutting out. So in that case what we can do, we have number of cylinders for an example. In that case what it does, when it reaches to that temperature, depending on how much is the deviation plus when it is reaches, it will cut off certain unload certain cylinder. What does it means? Once it is unloading certain cylinders, the capacity of the compressor is reduced. What do you mean by the capacity? Capacity means the mass flow rate will be reduced because now less mass will go through the compressor. In that case, we have the evaporator coil through which the refrigerant is passing through at low pressure, and then it getting evaporated, and when it is coming out, it is coming out from the flow. For an example, this is the evaporator. So this will be at low pressure and it is liquid and very little quantity of vapor because of the thermostatic expansion one and because of the flush evaporation. And then this will be at the end, it will be 4 to 7 degree super. This will be the superheat at the end of the evaporator coil. That will change the state and then it will come in vapor for the superheated condition. That is the gaseous form of the vapor mixed with vapor, and it will be 4 to 7 degree superheat will be having at the end of the evaporator coil. Now, what it does here, we what we can do, we can unload certain cylinder. Once we unload certain cylinder, suppose we have cylinder, number of cylinder we have, and this is the compressor, and we have some cylinder we cut off. And once we cut off some cylinder, then what will happen? Mass flow rate through this evaporator will reduce. Once the mass flow rate is reduced, the heat transfer rate will reduce because of the mass flow rate has reduced. In that case, what will happen? Suppose the temperature has reached to the required temperature, then there will be a mass flow. Now suppose the temperature has increased, then what will happen? The mass flow rate will has to increase. The mass flow rate will increase. Suppose we have cut off, it was running at 50%, it means 50% of the cylinder is cut off. Now we start 20% more. It means now, for an example, it was 50% capacity it was running, now it is 70% capacity it's running. How we have increased? We have loaded some more cylinder and the mass flow rate will increase. And the mass flow rate will increase, what will happen? The cooling rate will increase. your temperature will reduce and come back to this temperature. So we do the unloading gear, that is the cooling capacity we do adjust. This cooling capacity of the coil will be adjusted according to the how many cylinders are loaded. It means the capacity, it is 25%, 50%, 70%, 75%, 100%. We usually use that. So it will run at that capacity. It will not stop. Instead of stopping, cutting in, like the refrigeration system we have seen, we use cutting in and cutting out. In this case, most of the cases we have that it is continuously running, only loading and unloading of the number of cylinders. It will depend on the how much load is, cooling load is here. Cooling load is equal. So the mass flow rate is adjusted. So let us see the compressor. This type of compressor we have the like the previous one I had drawn a V-type reciprocating compressor. We can have, this is one of the rotary compressor we can have, and it is driven by the electric motor, and we have the shell and tube type heat exchanger, which we use for the air conditioning refrigeration cooling system. That is the refrigerating system, cooling as well as the dehumidification system. And this type of compressor we have the these are the screw type compressor, because where we have large capacity is required, there we use the screw type compressor. For an example, the passenger vessel, even VLCC, ULCC, we do use this type of compressor because the capacity is very high, where the mass flow rate has to be high. Whereas for the reciprocating compressor, it increases the pressure very high, but the mass flow rate is less. So large capacity for the cruise, the passenger vessel, they use this type of screw type compressor, because they are, you need very, very large capacity, because there are hotel accommodation for the passengers. That has to be also conditioned. This one we have shown, and this type of compressor, then how the capacity is controlled. In this type of compressor, there is a slide valve, and then slide valve moves. There is a hydraulically it is moved, and when the slide valve to change the position, it means suppose we have a screw here, screw here, and the screw, what will happen? The screw size will reduce as you. For an example, this is a single screw. For an example, and what will happen? The screw is rotating, and this volume which is entering from here, which is at larger volume, because this volume is higher, as it is moving, because screw is rotating, but screw is not allowed to move axially. Then what will happen? The fluid has to move. Fluid will move, and then as the fluid is moving towards this direction, the volume is reducing. As the volume reducing, pressure is increasing. Now there are different lobes. Now, if there is a slide valve at the side, this is the slide valve, and this slide valve is covering the ports, which is outlet, then the delivery of the compressor. And this slide valve, as it moves, suppose we want 100% capacity, this will move this way, so that it will allow the flow through this. It means it will get compressed completely and then come out. And if we want the reduced, then what will happen? It will take outlet from here. So internally there will be a slide valve which is moving, sliding onto the side of the outlet. Accordingly, it is allowing which port to open. If we want to reduce the capacity, we move this direction. If you want to increase the capacity, we move this. So the pressure will be increased, or the mass flow rate will be increased. And this is done hydraulically. There will be a hydraulic cylinder, and this will connect to a rod, push rod, and with that it can be slided inside the compressor. And this will depend on the what is the outlet temperature of our AHU. That we have seen, there is a sensor, temperature sensor, which will sense what is the deviation, the measured value and the set value. Accordingly, if the measured value is less, means the increased, then the set value, it means more cooling is required. This will capacity will increase, and the mass flow rate through the evaporator coil will be increased. Exactly the same way. The mass flow rate part is same exactly whether it is reciprocating or screw tie. Only screw tie we use where the large capacity is required. There we use the screw tie. Then this one we have seen that this is a water inlet and outlet, and this type of condenser we will use, that is the shell and tube type, and these are the buffers. This in details we have already covered in heat exchanger. I'm not going into the details because you have already covered. But if you have any question, you can ask. So these are the buffers, which is changing the direction of it maintains a pressure drop into the system, and then it gives additionally it gives support to the loops also. And this is the inlet, and this is the outlet. It means this is the refrigerant, and this is the cooling water. So this is the now there can be a oil cooler which is cooled by a refrigerant. So in large capacity air conditioning system, we have oil which is cooled, and then it goes back to your. It means oil separator. After separating the oil, it comes to this cooler, and then it goes to the compressor tank. And this can be cooled by, it can be cooled by water cooled, it can be refrigerant, cooled by refrigerant also. Both way it is cooled. So the refrigerant will take the heat from the oil, and oil will cool and going back to the system, that is the plant. And refrigerant will remove the heat from the oil and then coming out to the system. So how it is done, for an example, this, if you see this, look at this diagram. This is the condenser, this is the receiver. And from the receiver, part of the refrigerant, liquid refrigerant is passing through this cooler. Once it is passing through this cooler, it takes the heat from the oil, and then it goes back to the, once its temperature is increased, what will happen? It takes out the latent heat, it means it will change the state and the pressure will increase. Once the pressure is increased, it goes back to the receiver. And then it get condensed again. So it will be, flow will be like this. So this is the refrigerant, it is going back to the receiver, and it is oil cooler is cooled by the refrigerant. Not by the water. It can be by the water also. This is one of the system. Many vessels they do use, a large vessel they do use, where the oil cooler is required. It is cooling done by the refrigerant itself. So this is one of the system of oil cooler. And oil temperature has to be also maintained for the compressor. So how it is done? It is done by the thermostat. It means it is, this is the three-way valve. So oil is coming to the cooler, and this is the outlet, this is the inlet. So outlet, there is a three-way valve. How much it will get a mixing, which is going to the compressor, the temperature can be maintained. It means suppose temperature is 46 degrees centigrade, it is to be maintained. So accordingly, it will mix, and then it will go to the compressor. Then return back to the compressor. It means from here, the oil is supplied, that oil inlet and the return line, there is a three-way valve on the return line. So there is a, now this valve is, now tell me Is it a mixing or dividing valve? This one. Can you hear my question? Have you understood my question? We have a three-way valve which is maintaining the temperature with the help of the thermostat. Now, this type of a valve, when we have put it in the outlet of the oil from the cooler. So, is it mixing or dividing?
I think it's a mixing one, Chief.
Yeah, that's correct. So, two liquid fluid will come and mix, and then it's going to the compressor. This is the mixing type of valve. If it is put here, then it will be a dividing. For an example, we put here. So here, this is the flow. It is dividing. Part of it is moving up. Part of it is going to the cooler. So it will be dividing. But we put it in the outlet, and it is a mixing type three-way valve. So depending on the temperature to be maintained, how much will be the mixing? It's exactly the same. What we do, we mix two fluid, and then we can maintain a temperature. That temperature will be in between temperature of one will be high temperature fluid, that is the same fluid we are mixing. One will be high temperature, one will be low temperature. After mixing, it will be in between some equilibrium temperature. It will come to, and then it will go to the compressor, and we have a set value how much it will be maintained, and accordingly the mixing proportion, that mass of how much mass will be mixed, it is decided. So in this case, like that three-way valve, what we have seen in cold position, what will happen? The B is the hot oil, and this is the cold oil. So in cold position, what will happen? This will come like this, and wherever in warm position, it means this is the warm oil and this is the cold oil. So cold oil, it means when it is sensing high temperature, cold will come. When it is sensing cold, the warm oil will. So this is the way three-way valve in this system it works. So is it clear this three-way valves, how it works? Cold position means when the temperature is less, that time the warm oil has to go. And when warm position means that time that cold has to, it is sensing high temperature. This is sensing low temperature. And it can be mixed also, in between it can be. And this is the compressor. You can see this is the screw compressor. If we use screw compressor, when it is used, it is like this. And then, as I told you, as it moves the fluid, the volume is reducing. The design is made such a way so that the pressure is keep on increasing. Volume is reducing. Same mass of refrigerant is getting compressed. So the pressure is increased. That means the density will increase, so mass flow rate will increase. Now, the unloader, how does it work? The compressor, now, like the air compressor, we have the unloader, we have a solenoid valve which is opening and draining the air. But in this case, we cannot do it because it is refrigerant. We cannot release the refrigerant. Then what is it, how it is done? The suction valve is kept open when the unloading condition. And when it is loaded condition, that time suction valve is in normal position so that the compressor can compress the refrigerant. Otherwise, if it is you keep the suction valve open, suction valve plate, suppose you push it down, then what will happen? Suction valve plate will remain open. Then compressor is piston is reciprocating, but as during the compression the refrigerant will come out through the suction valve, so there will not be any compression. That's the way we unload it. So in this case, if you see the discharge pressure, there is a solenoid valve here, and there is, let us see the component. This is the suction valve, and this is your valve holder, and this is the suction, and this side is the discharge. So this is suction and discharge, and from the discharge, one passage is here, if you see. So this passage, the discharge pressure is coming here, and then this passage is connected to this. There is a piston here with the Teflon plate. This is the piston, and there is a spring on top of the piston, inside the piston. The spring is pushing it down, and if you see this discharge pressure which is coming here, which is pushing it down. So in a normal condition, when the it is not loaded, it is unloaded, then what will happen? This spring will push this piston downward, and this will push the valve in open position. So against the spring, valve has got spring, against the spring, valve plate will be pushed down, and it is kept open. Now, when this is energized, it means we want to load it. Once we want to load it, we will energize the solenoid. Once solenoid is energized, this discharge pressure will come here, and it will push the piston up against the spring. Once it is pushing up against the spring, then what will happen? This valve, now this has got your valve plate, and this has got a clearance. It means now the valve can operate normally during the suction, and the pumps during the suction, valve will be open by this because of the pressure difference, and when during the compression, valve will be closed because the inside pressure will be higher than the suction pressure. So it will be in closed position, so the normal compression will happen. Whenever you want to load it, it will get energized. It means when suppose we stop the compressor. When you stop, when it should be in unloaded condition. So it gets unloaded because that time this solenoid valve will be de-energized. And then this spring will force it downward direction, and it will push the valve plate downward direction. And whenever it is now, when you start the compressor, that time what will happen? This solenoid valve, all the solenoid valve will be de-energized. So when you start the compressor, it has to be in unloaded condition. So all the suction plates, valve will be in open position. After that, once it is a time harvest in that case, because after that, when it is coming to the normal RPM and the amps is normal, after that it will be loaded. Initially for starting, all will be in unloaded condition. After that, depending on the temperature sensor, that set value and the measured value, what it is, accordingly it will be loaded. So automatically it will be loaded. How many cylinder? Each cylinder has got this unloaded. So how many cylinder it will be loaded, so that it will be accordingly the compressor capacity will be adjusted. Is it clear, everybody, how the unloading is done in refrigerate, means the air conditioning system, refrigeration system, that is the cooling system compressor. This diagram, is it clear to you? And the operation, what I said, how it functions? Yeah, Abraham, tell me. Yeah, Abraham, tell me. Can you hear me? Abraham.
Yes, Chief, can you hear me?
Yeah, I can hear you. Tell me.
Okay, so this unloader is mounted on each cylinder units, right?
Yeah, each cylinder unit on top, cylinder cover.
Yes, but yeah, it's not driven by oil also, looks like.
No, it is not driven by the oil. It is driven by the, it can be driven by the oil also, but in this case, it is driven by the our uh, discharge pressure. This is the discharge. This is connected to it.
Yeah.
So there is no chance of mixing if you operate this by the oil. In that case, there are chances of mixing. Of course, the oil has got a property, it can separate, and we have the oil separator where it gets separated and converts to the crankcase. In this case, it is not oil operated. So we can have oil operated, like we have a piston, and this is the spindle which is pushing the valve in open position, and there is a oil pressure acting on it. There is a solenoid valve which is a control valve. It means in normal condition it will be drained, and when we want to in normal condition it has to be in open position, that is the unloaded position, and when the oil pressure comes, that time it's it's closes so that it is in uh, it is in a loaded condition. It means this will push to keep open when we want to unload, and when the oil pressure comes and acts on it, it will uh, remove from the position. For an example, we apply oil pressure on this face. Then what will happen? This will have a movement down. So in that case, it will be in loaded condition. And when it is, it means when normally it will be in unloaded condition. If there is a power failure, for an example, this solenoid valve, it means it will be in unloaded condition. So this piston, this spindle moves up and down by the oil pressure. Oil can, this position changes, oil gets drained and it moves down. And for an example, if we have this connection on top, both way you connect, then what will happen? In oil pressure, it moves down. In that case, valve is, this is the spring for the valve, and the spring will push and it will keep in closed position. So your compression will be, compression will occur. If this gets released, then what will happen? Or this is giving a pressure from here, that time it can be spring loaded this side. If you have the spring loaded, when this gets strained with the spring force, this will push the valve in open position, so there will not be any compression. There are various arrangements, it is there. The main thing is you cannot release it. Like we do a draining, the drain is kept open for the air compressor, and like that, we cannot do it here. We need to have either this arrangement or this kind of arrangement. Both arrangement we can. Is it clear? Abraham?
Yes, Chief, it's clear. Thank you.
So there is another
Chief, your mic is muted.
Yeah, can you hear me now? Yeah. So this is the flush evaporator. This, the high pressure liquid is coming here. And this high pressure liquid will have the higher boiling point. And this is going to the saturated liquid, which is going to the evaporator. And what is happening here? So in that case, there will be a heat transfer will take place. It means when it is the high pressure liquid is coming, and then this is in a liquid. So when it is passing through this, it means it's coming here. Then there is a level is maintained so that the oil, what is the liquid which is going to the separator, not the gases is going to the. So this type of arrangement, if we have also for the air conditioning system, what is happening? The high pressure liquid is coming here, and then it the reduces. It means the pressure saturated liquid, only the liquid, it goes to the evaporator system. That is the cooling coil, and once it is coming out, then what will happen? We are not adding any heat energy or removing any heat energy. Now, here the pressure is high. Once it enters through the nozzle, the pressure is low. The pressure drops here. And once the pressure is dropped, well, what will happen? There will be a flush vapor, and there will be a liquid which is moving downward, and there will be flush vapor also. And to get vaporized, what will happen? The temperature of the liquid will reduce, because we are not adding any heat energy, we are not removing any heat energy. Then from here the heat energy will come from evaporation, because part of the liquid will get evaporated. So it will come from the within the liquid itself. So the liquid pressure also will increase, reduce, as well as the temperature also will reduce, and certain amount of flash vapor will generate. So this liquid at low pressure and low temperature then will go to the evaporator. So what will happen to these gases? Those are flash gases that will go to the compressor. There is a suction in intermediate point. It means at intermediate point, there will be a suction, and that will enter to this, to the compressor. And then it will get compressed with this suction, and then it will go to the outlet of the compressor. Now the problem is the pressure. It means the pressure has to be maintained when it is coming to the intermediate point. If the pressure difference is, if the inside pressure is higher than this, then what will happen? There will be a reverse flow. So that is the reason pressure is maintained. This is the pressure regulating valve, which is maintained so that the pressure at this point does not fall below the compressor inside pressure at this point. So this is the economizer we do use, and then we change because here the pressure and the temperature of the liquid is reduced, and then it's going to the evaporator point. This is one of the system, mini vessel, large vessel we do here. So this kind of economizer also we do use on the on board the vessel for the air conditioning system. Yeah, Melissa, tell me.
Thank you, Chief. From this diagram,
Yeah,
I see this the gas from the vessel. It's going directly to the compressor. This means it's bypassing the evaporator. So it's passing without doing work.
yeah.
How we can say this is economizer? I don't understand how we make economic from here.
This was, as we know, the latent heat is much higher than the sensible heat. So the amount of gas it will create and it will go to the flash, it will flash off. It will be, quantity will not be that much. What will happen? The amount of temperature reduce, pressure will reduce because it is coming out from the nozzle. From high pressure, it will become low pressure, as well as the temperature also will reduce. The benefit we get from here, the latent heat is given by this gas, and that is become a sensible heat for this because the temperature is reduced. And that amount, if you calculate the gain and the loss, gain is much more. That is the reason in large vessel we do use this kind of economizer. Even passenger vessel also we do use, as well as ULCC, VLCC or VLOC. We do use this kind of economizer also is designed. So always it is calculated what is the loss, what is the gain. In this case, gain will be much more than the loss. Because of this, your here we are sending 100% liquid, saturated liquid. We are not sending the liquid plus vapor. So this vapor will take the latent heat in the evaporator coil. This vapor will take the sensible heat, and this liquid will take the latent heat. Here, 100% latent heat it will be taken because it is saturated liquid, because there is no vapor in this. Vapor is being removed from here, and then it is sent back to the compressor. And there is a demister so that no liquid should go to the carry with the vapor, because when it is going to the compressor. So this latent heat is always higher than this. Here it is completely liquid, so the latent. Here in other cases it will be that latent heat is much more higher. It means this latent heat will get evaporated in evaporator coil, and the latent heat will be taken from the air to get evaporated, and that quantity will be much higher. So that is the reason it is called economizer vessel. So it gives us the benefit of the cooling efficiency of the evaporator. Melissa, is it clear to you?
Yes, Chief, it's clear. Thank you.
So now the handling unit, where it is installed, usually it is installed in the board deck. At high level, it is installed air handling unit, and it will be outside the engine room. It can happen also that the machinery, refrigerating system, machinery is located in the same room where the air handling unit is there. It might not be necessary, might not be also. There are ships designed where the refrigerating machinery is located in the engine room. In that case, what will happen? The piping from the machinery, um, refrigerating machinery system, that is the after the dryer, it will be means if there will be a long piping which will go to the air handling unit, which will contain the our cooling coil, which will act as a cooler as well as the dehumidifier. So, and the cooling is usually it is a seawater circulating pump we have, so that the air conditioning seawater circulating pump which pulls, or you can have a THT system, that is this will be seawater and LTHT will be the fresh water. LTHT system, the LT water will cool and do the cooling of the condenser. So this both the system is existing nowadays. Why it's and air distribution system, that is the air handling unit. After that, we have the ducting system. We have seen the single ducting, double ducting, and the local heating system, local temperature control system. So after the air handling unit, the ducting would go to the all over the spaces, the conditioned spaces, and the sound, because when the air is mass of air is flowing through the duct and it is coming out to the cabin, there can be a sound which might not be, there can be a noise which might not be comfortable to us. It means the volume has to be regulated such a way, design should be such a way so that there should not be a noise or the sound which is uncomfortable. So it is designed such a way. Now there are certain things we need to know. That is the procedure for pumping down, leak test, and refrigerant charging and the oil charging. Because we have the refrigeration for the cooling and dehumidification. Pump down, what does it mean? Pump down, it is a collection of the refrigerant in the condenser temporarily. It means, suppose we don't want to use for like standby unit you have that we are not using now at the moment. So what we do, we collect the gas to the your condenser, and we want to do some maintenance. We collect and the gas into the condenser. uh, so there are various situations when we collect the gas. Temporarily, we collect the gas into the condenser. Now, how will you collect? It means we have a condenser. After the, it means we have a compressor, and then after the compressor, we have the oil separator, and after the oil separator, it goes to back to the separated oil goes back to the compressor, and then it going to the condenser. And condenser from here, and suppose let us consider that the condenser and the receiver is same. It means lower part of the condenser is the receiver, and then going to the your dryer, and then the flow side plus, and then solenoid valve, and then hemostatic expansion valve. This is the solenoid valve. Then thermostatic expansion valve, and then evaporator coil, and then goes to the compressor. So this will have a sensor which is outlet to the evaporator. Now, what we do, we supply the water to the condenser. So the water is supplied to the condenser and open the compressor suction valve. It means this suction valve to be open. After that, your inlet valve to be condenser to be shut. This will be shut. So you have opened this, your discharge valve is open, and it is coming to the condenser. Condenser outlet is in that. After that, what you do, condenser outlet valve you shut. It means this discharge valve is also the inlet to the condenser. After that, what you do, start the compressor. Once you start the compressor, now the condenser containing the refrigerant will not come to the suction side of the compressor because we have closed this. So whatever the refrigerant from after this valve to this up to this section will come to the compressor. So the compressor will suction will take place up to this. Then what will happen after the compression? It will go to the condenser. And in condenser, it will get condensed, and the liquid level you will see in the side plus the liquid level is. So since the outlet is shut, it will get collected in the condenser. Then you stop the compressor, when the pressure, suction pressure will keep on reducing because there is no flow after this. So as the compressor is started, slowly pressure is reduced. So once the pressure reduces to 0 bar, then you stop the compressor. And you stop the compressor, after that what will happen? Slowly again the pressure will increase because this will increase the pressure and the suction pressure will increase. Slowly it will flow to this direction. And also it will get evaporated also. And as the evaporation takes place, the pressure will increase, suction pressure, and the flow will be into the compressor. So once this pressure gauge will increase, showing the suction pressure is increased, again you start, again at 0 you stop. You do 3-4 times depending on the capacity of the system. So around 3-4 times, if you repeat this, then all the refrigerant will get collected here in liquid, and from it will get condensed and the liquid level will increase. You know all it is collected. After that, you will see the pressure is not increasing, or it is increasing very slowly. So it means all the gases is collected to the node condense. So after that, you stop the, immediately what you do, once you collect it, you stop the suction. And then the suction valve of the compressor, you will shut, and the liquid inlet to the condenser. Suppose this is the liquid inlet valve, the delivery, you shut. So you have isolated now the condenser from the system, where you have already collected the gases, and it will be in the liquid. Once it is in condensed form, it will change the gas to the liquid because water is flowing, and if you keep the water flowing through that. So once you finish it, then you can stop the cooling water, because now you have isolated these two. Sometimes you may have a valve here, so you isolate. So your gas is containing in the compressor and the condenser, and it will remain there. So this is the pumping down or the pump down procedure. Is it clear, everybody? Any
Yes, sir.
question?
It's clear.
Okay. So the next is the leak detection. The leak detection is the easiest way. What we do on board the ship, we use soap water. We put some soap and we stir it. It will form a soap water, and then with a dog leg brush, we can put it uh, on the suspected areas on the leakage, where we can suspect a leakage. For an example, the pipeline where the joint is and the valve is, and then we have the means where the probable leakage it can happen. Any joint we have there in the valve gland. These are the places where it can leak. So we put the soapy water, and then what will happen if there is any leakage? Then it will form a bubble, by which we know that visible. It will clearly visible. That will be the indication of leakage. It's a very simple way and easiest way, and one of the best way we can check this leakage. Now there are electronic leak detector also. So in electronic leak detector, it means there are various type of electronic leak detector we have. So in this, the maintenance of this detector should be maintained properly, Otherwise, what will happen? It might give you the wrong reading. There are maintenance for the electronic leak detector, like sensor. Often you need to change filters. You'll have to clean the filters. Otherwise, it will not take the sample. So it has to take the sample and measure it and give you a reading. So the contamination of the detector, if the oil is carrying with the sample, it will touch the sensor, and what will happen? Sensor, it will adhere to the sensor surface and it will give you a wrong reading. So that's the reason replacement of the filter. It's very important, and regularly, if it is disposable type, we'll have to replace it. If it is, you can clean it. If makers means as per the maker instruction, you can clean it and reuse, then you can reuse. But these are the problem you can have with the electronic leak detector, so which might lead you a wrong reading. So there are two types of commonly used. One is heated diode. What is heated diode? A detector. So this is the diode which increases the temperature, and you can see here this heated diode. It has to be sensor has to be changed every after 100 hours of use, because otherwise after that the life of the this detector, the sensor, is 100 hours. So after that, it will not function. So another type we have, it means the heated diode. What it does actually, it increases the temperature. Once it increases the temperature, it can sense the this is like the concentration of your refrigerant. It changes the resistance to the diode. And depending on that, it can detect that how much it has changed and how much is the concentration if there is any refrigerant. If there is any refrigerant, it has got change in resistance, and then that resistance can be converted into, it means the current flow through that will be changed, and how much it has changed, that can be calibrated to how much concentration of your this refrigerant it is in the sample. It means if there is any leakage, there will be a change, because that gets burned at that temperature, and it will change the resistance, and the current will flow will be changed, and then accordingly your uh, so this is heated diode is one of the detector. You can sense the leakage. If there is any leakage, it can detect. Then there is another one is infrared. Infrared detector means this is another type of detector what is used. In this detector, what happens? The infrared rays is passed to the in the sensor, and then what happens once the sample is passing through that ray, the infrared ray, it absorbs some energy. Once it absorbs energy, it will be absorbed by certain wavelength will be absorbed by the infrared ray uh, by the your refrigerant when it's, which is containing in the sample, and that particular wavelength will be absorbed by that particular your refrigerant. Once it absorbs, then what will happen? It is, suppose the ray is moving in this direction. This is the ray is generated here, and we know what is the wavelength. Accordingly, it is passing through, and sample is moving this direction. When the sample is moving this direction, then what will happen? There is a sensor which is measuring how much energy is reduced. That much, that particular wavelength will be only absorbed by the refrigerant. Now this energy level has reduced, and how much it is reduced at that wavelength, that is absorbed by your refrigerant, and that can be converted into if there is any leakage or not, and it will give the scale also how much it is. Small leakage, iron leakage, you will see in uh, the monitor, it will give you how if the concentration is high, it will give you high. Because concentration is high, the energy reduction will be high because energy absorption will be high by the refrigerant. So this sensor is measuring that particular wavelength which can be absorbed by the refrigerant. So, and this is supplied by the instrument only, so we have the control over it. We know what we have supplied, infrared ray, which wavelength we have supplied. And accordingly it is measured, and accordingly it is directly it can be give you a reading what is the if there is any leakage and what level of leakage means small leakage, large leakage, all it in the display. So this is another way we can have it, this leak detection we can carry it. Then another is ultrasonic. What is ultrasonic? Ultrasonic is the sound. Now this is the pipe. For an example, this is the joint, and this joint has got a small leakage. What will happen? Why there is a leak? In what? How the refrigerant is coming out? Because this pressure is higher than the atmospheric pressure. In that case, what will happen? Once any pressure drop, there will be a velocity, and that velocity will make a noise. It will make a sound, generate a sound. It might not be audible to us, but there has to be a sound when a fluid is coming out from high pressure to the low pressure, if there is a leakage. And this is sensed by the ultrasonic detector. Once it senses, then what happens? Which is not audible to us. If you go to that area, there is a leakage, but we cannot find out from our means from our ear that we cannot listen to that. We can hear this sound. But this ultrasonic detector can hear the sound and it can detect the sound. And what they did after that, they amplify this and convert into a sound which is audible to us. It means we can hear the sound. So this sample, once it's drawn, it means it sound, it is detect and then amplify and then convert into a sound wave which is audible to us. Then we know that there is a leakage in this area because this sound will be different than the other vibration and noise. Because this will be a sound which is because of the pressure, and that is detected by the ultrasonic detector because there has to be a turbulence because of this pressure drop and the with high velocity the fluid is refrigerant is coming out, leaking out from the system. So this is the way it is, and this can convert even audio, visual, alarm. It can sound. It means it will give you a alarm, and also audio and visual. Also, it means it will be in display that there is a detection of the refrigerant leak, as well as it will give you an audio so that you can hear a sound. Like suppose it gives you beep, and that pet pet means any beep it gives you. So it means it is there is a leakage in this, and it is always converted into a sound, natural sound, which human ear can easily identify. Because we cannot identify all the sound. Those are the natural sound which we can identify. So this is another way we have detect the gas. Now there is halide torch. This is one of the way we can check what it does actually when it is you bring this torch, that is the flame, close to this area where you suspect the leakage. Then what will happen? The chlorine atom, because of chlorine atom, it when it is exposed to that refrigerant, if the refrigerant containing the chlorine atom, then the flame color will change. So flame will turn to green. But the modern refrigerant, it will not be able to do. Now from 1st January 2020, we are not using HCFC also. So this was phased out before. On 1st January 2020, this has been phased out. The modern refrigerant does not contain chlorine. So even if you have, for an example, on board the ship, if you have a light torch, if it is not compatible to the HFC, you cannot use it. Do not use it. It will not give you any indication because it does not contain. Suppose we are using HFC because it is a requirement for since 1st January 2020. But previous stock was there. Now, if you want to use this to detect this, it will not be detecting because it does not contain the chlorine atom. So this is another way, then another method of checking the liquid, but modern from modern shapes means modern refrigerant, we cannot use this. So the refrigerants leakage in the condenser, it can happen. Sometimes you see you check the leakage everywhere in the system, there is no leakage. But you see you keep on charging and the refrigerant you are losing, keep on losing the refrigerant. It can be from the condenser. If it is from the condenser, you will be able to make out from outside because it will leak because the refrigerant pressure is higher than the seawater pressure. It will leak to the seawater and it will go to the sea overboard, or it will go to the LTHT system. You will see in LTHT system, you will see the expansion tank, there will be bubble because the gas has to escape from somewhere. From where it will escape? It will escape from the expansion tank. So in this case, what will you do? You open the end cover, that is the water box. Once you remove the water box, then what will happen? And then you bring the gas detector close to the tube plate, and you will see it will give you a indication that there is a leakage because the tube is leaking. There is a failure of tube. That's why the gas is leaking through the tube, and it has to come out from the tube plate because tube plate has got a tube is attached to the tube plate. So this is the way we can check the condenser leakage. If you suspect condenser leakage, it means you have to remove the water box, drain the water, and then you have to use the gas detector to check. Bring the gas detector near to the tube plate and you can check. Okay, so Abraham has a question that if we use the halide lamp, then there are chances of fire. It is a fire hazard. Now, number one, now we cannot use because even we can use if it is compatible to its HFC. But when you are using the torch, you have to be, you as a person has to be taken the safety measures so that it does not catch fire. So this you can keep a bit away from that. You don't have. It's not needed that you will be taking the flame and touching the on the surface. So you can keep it because once it is leaking, it means it will be surrounded by that area. It means it will be even if you keep certain distance, safe distance, it will be changing the color because where it is there is a lagging, where are chances of getting fire. So that area you can avoid it. There is no problem by using it. On ships it has been used, but you'll have to consider the safety. Uh, you'll have to take the safety consideration. There should not be any fire, and then you can, considering that, you can use it if it is compatible to the modern refrigerant, that is the HFC, which does not contain the chlorine. Yeah, Sophonis, tell me.
Thank you, Chef. About this ultra ultrasonic detectors.
Yeah.
Is it possible to detect some other sounds from the machinery space, or it's specially only created by these leakages only?
Yeah. So this one will detect only the pressure differential. It will be detecting. Machinery space, there will be many vibration, noise. Those noise are different. That is because of the vibration. And this one will be because of the turbulence. It can detect which one is for the turbulence, and your sensor will be close to that. So it will detect that noise which will be produced because of the turbulence. If there is a leakage on this surface, suppose this is the it is coming out from here. Once there is a, this was supposed streamline, but once because of this leakage, once it is coming out, then there will be a turbulence, and this turbulence makes a noise, and it will detect that. And suppose there is a machinery, there is a some machinery is operating. That time, what will happen? It will make a noise because of the vibration. That noise is different. These will pick up this noise, which is because of the turbo. And this noise in normal, this is not the normal noise which we can hear. We are not able to hear that. That wavelength it will detect and give us the amplify and make it for us so audible to us. So is it clear, Safines?
Yes, but my question was not the sounds that are created by vibration. I mean, from the engine sound or something.
Yeah,
I was
engine.
thinking some
Yeah. Tell me.
throttle valves, maybe they will create. Throttle valves maybe create some noise.
Throttle valve is inside you are talking, correct? So that throttle valve, suppose there is a throttle valve. So there will be a sound which is passing, hissing sound. We can hear actually that sound. But this is for the leakage. And this will detect which we cannot detect. So it will sense that if there is a leakage and we can hear it, then we can detect by our five sense. But it will detect some sound which is the turbulence which we cannot detect with our ear. Understood? So it will detect
Okay.
of that wavelength. It will not detect even if it is passing through. Suppose there is a throttler and some sound which is generating, we cannot. But this sensor, we can move, put it in this position. And turbulence, when the gas is leaking, the turbulence will be, it means we can keep certain distance. We don't have to keep exact one the surface of the piping. So it will, because with the high velocity it is coming out. Though it is coming out, but we cannot hear it. So this sensor will detect. We can keep it a distance. And inside the sound, it will contain inside. It will not come out. It will not make any turbulence on the atmosphere vicinity, in its nearby atmosphere. So it will detect that turbulence which is nearby vicinity. Hence it is in the atmosphere. So suppose there is another leakage, for an example, so it can detect that. But when you are putting this, it will be bringing close to this that system, the refrigeration system for the air conditioning system. You will be going through this line. It will not go through another place. It means it will be distant from the other pipelines. So if you see your refrigeration system or the air conditioning system, it will be an independent line, and there will not be any other pipe passing through it. So there will be a safe distance between the pipes. So you can keep closer to this pipe and the joints, so you can find out this. It can detect, because if it is internal sound, it will not coming out to the atmosphere. So it will not detect that sound. It will detect the sound what is turbulence created in the atmosphere in the near vicinity of that indication, and it will be outside. So this is the way the condenser tube leakage we do. Check. Now the charging of the refrigerant. How will you charge it? So always when you are charging, remember first thing, pump down. Without pump down, do not do the charging. First you do the pump down, any maintenance pump down, any charging pump down. First pump down, then do the charging. How will you do the charging? There are two types of charging. One is gas charging, one is liquid charging. Nowadays, many ship does not even provide with the gas charging, but you can have gas charging also. Gas charging is on the compressor suction side, whereas the liquid charging is, this is the condenser outlet, this is the outlet of the condenser, and then it's going to the dryer, and dryer will have isolating valve and a bypass valve. So there will be a bypass valve. So dryer will have inlet, outlet, isolating valve, and the bypass valve. Your charging point, liquid charging point will be. So this will be the liquid charging point. And the gas charging point will be compressor. Here is the suction valve. And before that, there will be gas charging. And this is coming from your evaporator. Now, which one is better? So better we use the liquid charging. That is the reason modern ship many times will be saying that there is no charging point provided. Why it is better? Because if you charge a liquid, it means we are charging in the liquid line. Our liquid line starts from here and then goes to the evaporator, and then thus change of state takes place in the evaporator. So this liquid, once we charge, it passes through the dryer. Whereas this one, if you charge the gas from here to this point, it containing the contaminant, because we have received this bottle from shore. We don't know the condition in this bottle, whether it is containing the hydrates or not. Hydrates means it is the moisture. So if it contains the hydrates, then what will happen? That will cause problem to this system. Whereas if we do the liquid charging, then what will happen? When you are charging, that time this valve is shut. And it is passing, it has to pass to the dryer. You will see your charging point will be just before the dryer. So that immediately what the dryer is doing, it is absorbing the moisture. And if any hydrates is there in the refrigerant which is supplied to the vessel, this will be absorbed by this dryer, and after that it is the pure, it is the hydrate free refrigerant will be in the system. So that is the reason most of the ships will say now it is having only the liquid charging, but you can have both liquid and the gas charging. Now for the liquid charging, when you do liquid or gas charging, when you do, be careful. You see the bottle might be having a gas charging valve and the liquid charging valve. If you are using the liquid charging, then it has to be liquid charging valve. It means in that case, for an example, there is a liquid, because liquid will be there at the bottom. So that will be the liquid charging line. So that liquid will come out to the and enter into the system. Suppose there is only one valve. Many bottle is provided with two valves. One is liquid, one is the gas. It means there will be another valve which is the gas valve, which is connected on the top of the bottle where the gas is. And now the other bottle, it has got only one connection. In that case, what will do? Suppose this bottle is having only one connection. It is for the liquid here. Now you are charging the liquid. Then what you do is do the upside. You put the bottle upside down. So, and then you can use that single valve you have. You can use that valve. What will happen? The liquid will be here and liquid will enter into the. So you need to check this before you do the charging. Now let us see how the charging is done. So once you have the pumping down, you collected all the refrigerant in the condenser, then you know how much refrigerant needs to be charged because you have the level on the condenser. And depending on that, you know what is the normal level, you will fill up to the normal level. So that how much you are adding, that you know. Now, if you don't do the pump down, then what will happen? You don't know how much you are charging. You might be overcharging. You might be undercharging. So both possibilities are there. So open the bottle valve slowly. In that case, what will you do? The charging valve you connect, but this valve when you are connecting to the charge for an example, this is the charging valve which we have. We will be connecting this bottle with the hose, flexible hose, and this side is the system. It's going to be. Now you connect this tight, but you connect this, but don't tighten it. You keep it flat, so that when you open this valve, bottle valve, then this line is having the air has to be purged. You purge it, the air will come out at this point, and after that refrigerant will start coming out, then you close it. Then after that you can close it, and then you can open this valve slowly. Now once you have pumped down, your condenser outlet is shut. This valve is shut. So what will happen? You are connecting your bottle after the valve. It means now if you open this valve, then when you are pumped down, your suction pressure on the compressor was very low. Now you have connected this bottle and you have opened this valve. What will happen? The refrigerant will flow, and what will happen to the suction gauge will increase. Once the suction gauge is increased, it means you put it on auto, your compressor. What will happen? You have a set point of the start cutting in and cutting out. So we can, or for this, because not this system, air conditioning system, you might not be having that system. So you have to do it manually. So in that case, what will happen? So you see the suction gauge and manually you start. And then what will happen once you start, the after the compressor, it is going to the condenser level will increase because condenser outlet is shut. So whatever gas is coming from the bottle to the system, it will get collected to the condenser. When condenser level, if you check, you know that level is increasing because you are adding the refrigerant, and when it is normal level, that time you stop it. So you can, after that, once the receiver level is normal, after that you can disconnect the bottle. It means you shut it off. This valve has to be shut off. This valve has to be shut off. It means this valve you first shut off, and then this valve, and then you remove this connector. And there will be a blank on this. For refrigeration system where the charging point, there will be a cover which is a blank. So you blank it. Suppose there is any, by chance there is any leakage because of this blank, it will not leak. So after that, open the liquid stop valves after the receiver. After that, you open this Your compressor is on auto, so it will automatically cut in and cut. So it will be, so cutting in cutoff means this will be unloading and loading. It will not be cutting for air conditioning. It will not be cutting in, cutting off. Usually you can have that system, but usually because it is a large compressor, uh, it is a large kilowatt it is used. That's why it is continuously running. As I told you that unloading will be done and loading will be done depending on the air temperature. So this is the way we can, that is used putting on auto so that the loading and unloading will be started in automatic condition. This is the charging. Is it clear how the charging is done, the refrigerant charging? Yeah, Abraham, tell me.
So, Chief, during refrigerant charging, refrigerant being in gas form, do we need to follow all procedures for pumping down, or we can just close outlet of condensers and we can start filling refrigerant through compressor suction line?
So whether you do the gas charging or the liquid charging, you have to do the pump down first, pump it down, then you do the charging. As I told you, if you don't do the pumping down, you don't know how much to add. Now, if you do the pumping down, you have a level. Suppose this is the your side glass. This is the level. You'll have to maintain this level. So now, after pumping down, we know how much is all the refrigerant is collected in the condenser. So it is the this level. How much to add? We add this. If we don't pump down, then what will happen? Suppose you see there is no level in the side glass. You will keep on filling and up to this. Then what will happen? It will be overcharged because there is already in the system there will be a there will be gases which we actually, it means we did not collect it through. It might happen that you might there are chances always, and plus it is the right procedure to do the pumping down. You know how much to add, you add it. Whether it is gas also will get condensed, the uh, liquid level will increase. So whether you charge it to the liquid or the gas, it is the same. Pumping down, as I told you, always do the pumping down and then check. And how much quantity you have added, that has to be measured. Before starting, you must check the weight of the bottle, and it will give the light weight. It means the empty bottle weight it has got. It means that actually you don't require when you are charging. You have the weight, and then after completion, you check the weight. Difference is how much you have added. That has to be recorded. It is required for the refrigerant to. You keep a record how much you have consumed. So, Abraham, is it clear? Both the cases will have to do the pumping. Once you pumping down, after you do the charge. So this is must, and you'll know
Okay.
exactly how much level will be maintained, correct level, as well as how much you have added. That also record. You do keep a record in. There can be a separate logbook, or in the logbook you write down, engine logbook, chief engineer's logbook. So this is the way it is charging is done. So gas charging procedure is, yeah, Melissa, tell me.
Okay, thank you, Chief. I have one question on this, the charging procedure.
Yeah,
When we say the correct level of refrigerant,
yeah,
according to the site class inspection,
yeah.
which one is recommended? I mean the correct level when it's collected after pump down, or when it's running in the normal operation?
So when it is pumped down, it will be a level After even, for an example, we are not charging, we are pumping down. There will be a level. And when you are using, that time there will be a level. But both has to be visible. So when you are running the system, that time, for an example, it will be when you are pumping down, it will be slightly higher than the midpoint. And when you are running the system, it will be around midpoint. It means definitely it has to be visible in the cycles, and it will be visible. Design it such a way. So if after the pumping down, it is slightly higher than the 50%, that midpoint, and when you start the system, even all the three chamber, for an example, or two system we say, so all complete 100% capacity, suppose it is system is running. That time also it will be within the side class. It will be maybe slightly half or slightly lower than the half, but it will be in the system. It means when you pump down, it will be slightly higher than the 50%. Usually it is that way. So when you start the system, that time it is it will be maintaining within the side class, and it will be maintaining half or slightly lower than. So that way you will have to maintain. But it should not happen that you, after pumping down, you see the level in the side glass, and after that, when you are running, there is no level. There has to be also a level. Clear, Melasse?
Yes, Chief, it's clear.
So now another thing is oil charging. We need to charge the oil. So in oil charging, how you do the charging. So in this case, once you replenish the oil, you need to do the pump down of the refrigerant. So what you do after pumping down, you close the suction and the delivery valve of the compressor. And then you can take out the plug, oil fill plug. There will be an oil fill plug in the compressor crankcase, and there will be a charging procedure. It means it means your crankcase pressure. It means you connect your oil line, which is actually will be filling the uh, compressor crankcase, but your crankcase is pressurized by the refrigerant, because your tank case will be always pressurized by the suction pressure. That means the refrigerant pressure. And once the refrigerant pressure is there, it means you need to, if you are charging by gravity, then what will happen? So you'll have to create a vacuum in the compressor. Once you create a vacuum, then only it means the lower pressure than the atmospheric pressure or the heat pressure, then only you can charge the oil by gravity. So in that case, what will happen? You operate the compressor for 5-6 seconds, very little time you operate. Once you operate, your suction valve is shut, so that the suction pressure, crankcase pressure will reduce. Once the crankcase pressure is reduced, then what will happen? So now oil can be charged to the compressor. Suppose this is a compressor, and this is the, it means we have shut this, we have shut this. We run this compressor 5-6 seconds. Then what will happen? So this, there is no flow from the suction, so there will be a low pressure created, and we have a charging point with the valve. So this, we have connected this with the pipe and the container. So this, it means this container is supplying this oil. Now this valve is shut. Once you see the pressure has dropped, after that You have stopped the compressor, then you open this pressure, because this is filled with oil, and this container should be clean container. There should not be any contamination when it is entered, and there should not be any air also entering it. You can remove the air from here to here by, it means the by purging. It means we can fill it up. It means you will have to keep it at higher level so that by gravity it will come and you can purge this air from this connection. After that, when you uh, open this, what will happen? This oil, this surface of the oil is having the atmospheric pressure on the surface, and then this pressure is sufficient now to push the oil inside, because inside pressure is lower than the atmospheric pressure. So this is procedure is risky. It means there are chances of contamination. It means air can enter, as well as that it is open container, because you'll have to have an open container so that the atmospheric pressure is on the surface of the oil. Otherwise, it will not enter into the tankers. So this is one of the way we can charge the crankcase. We can replenish the crankcase oil. If there is a leakage, crankcase oil level gone down, we can fill it up by this. It means it will depend on the, you have a side glass by which you can see the oil level, how much oil level you want to. What will happen once it is going inside? The air pressure is increased. At one point, it will be same pressure. No, nothing will move from this direction. So again, 5-6 seconds you start. You shut this valve. 5-6 seconds you start, and then again you do the same procedure, and you can reach to the required level of oil. This is one of the way we can do, but which is there are chances of contamination is high in this case. To avoid that, it means there has to be some other means of charging. So the charging hose, that's why it should be the lower than the oil tank, so that by gravity, otherwise this will not be, this air will remain there. Otherwise, oil will not push out this air in the tube which you have connected for the charging. And after charging, what you do, then you shut this valve, remove this connection, and then there is a blind cover. That cover, like that refrigeration charging point, there is a blind cover. Here also there is a blind cover which you will have to put. Yeah, Safnes, tell me.
Okay, thank you, Chief. So before we start this procedure, first we need to bleed out some oil from the compressor to remove the air from in the pipe, or how it is?
So this one you keep it shut. Okay, from here nothing will not remove anything. We remove the blind cover and we connect this point. Okay, and since this is at higher level, we can remove this air from this oil. Like this tube, what we can do, we can put oil inside the tube at higher level, and then this is not completely tightened. So what will happen? This air will escape, and then oil will start coming down, and then we tighten it. And this other end, we can put our finger, lock it so completely it will be oil, and then we put it inside the your this container which is containing the oil. So the other end, it will
Okay,
be
Chief.
submerged into
Okay.
the oil. So after that, you start this with low pressure is created, and then you open this oil will enter into the tank. After filling, after that you shut the valve, disconnect the hose, and put the blind cover on the oil charging line. And then after that you normalize everything, suction and discharge you open, and you restart the system. But this one is risky, as I told you. There can be a contaminant. The common particle, this oil can be contaminated because it is an open container. and air also can enter into this. There are chances of that. So in that case, what we do in this case, we have a supplied with a pump, that is the oil pump. So what we do, we use the oil pump, which we can increase the pressure. Hence, it does not matter that your crankcase is pressurized. We can isolate the uh, compressor, suction and discharge, and this is connected. And with the pump, with high pressure, we can fill up, and then we can see the level at required level. Once it reaches, we stop the pump, shut this valve, disconnect, and put the blank coil. So this is the way, this is the better way, because there will not be chances of contamination, and that pump is used for only for charging of the oil of the air conditioning and refrigeration compressor. Do not use that pump for some other use, because there can be a chances of then contamination. It is provided for that purpose, because other crankcase is not pressurized, so you can always fill up. You don't need this pump. So that is a better way to charge the oil. So that is another method of charging oil. And if you want to completely drain, yeah, they would tell me.
Yes, Chief. Thank you.
Yeah, tell me.
My question is why we need to recharge, because as I understand, it is a closed system where the oil will go. If there is any leakage, that means there is also refrigerant leakage. Yeah. So what is the purpose of recharging if it is really closed system?
Yeah. So any closed system also there can be a leakage. Now, one thing, there can be external leakage, which you can see that oil is coming out. And suppose oil is coming out from the seal, definitely it will refrigerant also will be losing. Now, thing is that suppose you cannot do the maintenance at that point, then what will happen? Suppose shaft seal is leaking, very minor leakage, but you cannot do the maintenance at that point. Maybe you don't have spare, or maybe some other reason you can. Then what will you do? You'll have to replenish. You'll have to replenish the oil to maintain the correct level. Though you know you are losing oil because of the external leakage. Now there can be a internal carryover of oil for some reason, and you cannot stop the compressor system and do the maintenance at that point. What will be the immediate corrective action? Because we cannot run the compressor at low oil level, so we need to replenish. And after that, definitely you need to do the maintenance where it has gone oil. It means in the case of shaft seal leakage, shaft seal leakage is a problem for the air conditioning and refrigeration system compressor. And if it is shaft seal leakage, you can see in that case what will happen, you will be losing oil as well as refrigerant. But suppose there is a carryover. Your oil separator is not separating correctly and returning back to the compressor. Then what will happen? Compressor oil level will reduce. But carryover, and it is not coming some certain percentage of refrigerant. There will be carryover. Because the oil will be carryover with the refrigerant. But that should return back to the suction. Suppose it is not returned back to the suction, because we cannot make it 100% oil free when the refrigerant after delivery, after the even after the oil separator, it is not 100% refrigerant. There will be some carryover of oil, but it should be minimized as minimum as possible. But that should not retain in the system. That should come back to the suction side. Suppose it is not coming back to the suction side, and level you see slowly, very slowly. Maybe once in a month you see, or 3 months you see, slightly it has reduced, and that is not safe. So you need to plenish. And at the same time, definitely, or even if it is uh, any reason it is not coming back or it is leaking outside, you need to repair, rectify. But in the meantime, the solution is to maintain the level, oil level, to run the compressor safely. Otherwise, your bearing will get damaged, and compressor crankshaft will be damaged. There can be more damage, adverse damage to your compressor. So to avoid that, lube oil is one thing. That is the first thing. Lube oil should be there sufficiently. Pressure should be there sufficiently, so that even if the system does not perform for some other reason, it will not damage. So that is most important. That's why lube oil is very, very critical. So we cannot run the compressor with low lube oil level. Is it clear? Understood, Dev?
Yes, thank you.
So now suppose we want to change the oil. Then what we do? In that case, what we do? We shut the suction and discharge valve, and then your crankcase pressure is higher than the atmospheric pressure because it is pressurized by the refrigerant. Now, if you open the drain valve, there will be a drain valve. Once you open the drain valve, with that pressure, the oil will come out. You collect it in a container, and then the pressure will keep on reducing in the tank. Now, suction and discharge valve is shut, so there will not be any flow of refrigerant inside. So the pressure will drop. After that, you will see the pressure will equalize. Now, atmospheric pressure, nothing is coming. Then you can open the cover. Once you open the cover, and by then the level will be lower than this cover. So we can cover open, and then it will be the atmospheric pressure and push it out in the remaining oil, and you can clean the crankcase completely, and then you put back the cover, and after cleaning, this drain has to be shut, and before that there should be flushing of the oil. So you use the oil, don't put back the cover. Before that, you will have to flush with the oil. You will have to flush the internal surface of the crankcase, and also on the bottom there is a little flushing, and after that you shut the drain valve. After that, you fill up with the can the oil, and oil level you check that it is the required level. After that, you close it, and then you restart the compressor. Now there will be some air in the crankcase which you cannot remove. How will you remove? You can remove it. It means this also when you do, you have done the pumping down. And after that, once you do the pumping down, this for this operation, cleaning the crankcase and removing the oil, you'll have to do the pumping down and do this. And then after that, what you do, you can purge it on the condenser. This air can be purged. Uh, this air will go to the condenser, and condenser outlet is shut. You have the water flowing through it. What will happen? Air is non-condensable gas. It will be in the top of the condenser. It will get accumulated in lighter, and then there is a vent provided on the condenser top, in which you can remove this air. You can see the air is coming, or your refrigerant is coming. Air will be at higher temperature than the refrigerant. You can fill it here, and once the air is coming out, little amount air will be there. This tank is capacity above the lube oil, that much air will be there, that can be removed through this. And air removal of air is there in its syllabus. I'll come to that. So that is the way air is removed from the system. After that, you can restore the system and run the system. Uh, is there any question till now? What I have taught you?
Yes, Chief, I have one question.
Yeah, tell me.
Yes. During pumping down a refrigerant,
Yeah,
normally the compressor will stop early because we need to pump the refrigerant until the pressure is coming zero. Yeah,
yeah.
that the compressor will stop early because of safety. because
Yeah.
when he sends low pressure, he will stop early.
So in that
So
case,
how we
we
make
have
zero?
to bypass it. If any safety which is interfering, because you are doing manual, you are there, you can monitor the pressure, the well pressure, all the parameters you are monitoring when you are collecting the gas temporarily in the condenser. If required, you can bypass that. There is no problem of bypassing that at that moment. Understood? So cut off pressure, or you can reduce the setting. Both ways. If you reduce the setting to zero, but you are doing for the refrigerator, this air conditioning system, you are doing manually. Usually, refrigeration system, they don't cut in and cut off. It's continuously running. And in fact, that is the reason the setting you can change and you can to zero bar pressure. Clear, understood?
Yes, I understood. It's clear.
So any other questions till now? Yeah, Sophonius, tell me.
Okay, thank you, Chef. So when we are changing the oil,
Yeah.
air is going to the crankcase, and we are letting this air to circulate throughout the system, or how
No,
we are going to do after finishing the change?
we are not allowing it. We do the pump down. It means uh, after that, what we do, we start the compressor, keeping the suction and discharge valve open, and the condenser outlet is shut.
We
And
do the
then,
pump down after
yeah,
changing the oil?
yes. After that, we do the pump
Okay,
down
thank you.
so the air will collect here. And also, whenever you do the maintenance, one thing, yeah, another thing, once you may do the maintenance, you will see you'll have to charge a little bit because you have pumped down, you have isolated the system, but some gases you'll be losing. That much you'll have to charge also. So, any other question? So, if no questions, then okay, there is questions all day. And Melase, one day you speak.
Uh, about the assignment, if it is possible, better we supply in Monday. We submit in Monday because I don't finish
No, no.
because of
Say again.
travel.
Assignment. Are you talking about the submission?
Yeah, the submission days of the assignment. If it's possible, better we submit in Monday.
That we'll see. But you have given 7 days time. I had given 7 days. So try to finish within that time. Okay.
All right,
So
for next year, next.
if
It's
we
it's not
consider,
only his question.
yeah. Tell me.
We also want chief. Not only him, chief. We also want because we cannot finish.
So one thing you remember, will this assignment is also giving you practice so that you know in the exam you have the limited time and you'll have to answer the questions within that limited time. So this improves you that skill also. So you must remember that also when you are preparing the assignment. And now the assignment is such that we are covering the chapter. After that, I am giving you the assignment, isn't it? It is like you have already covered the chapter, you have understood the chapter, and then you are preparing the assignment. So we'll see to that, but as I told you, you should keep that thing in mind. So the time frame is always kept like that because that will give you a practice. It means you will be preparing when you will be appearing the exam, you will be preparing that way. You know there is a time frame and within that time you need to answer. Is it clear? Understood?
If can you hear me?
Yeah, Fatana, tell me.
If you continue the assignment like this, I think it is bother for reading the time. It's already take time. the time all the times to make a assignment. We cannot get prepared for the readings. For me, it's difficult little bit, Chief.
So this has to be done in parallel. Understood? So your course will not interrupt because of the assignment. So you have to prepare the assignment, and the course also will go, and you will have to attend the lecture. And lecture we are conducting daytime 2 to 4 hours. There are gaps. It's not that continuously like physical lecture what used to be. And regarding the assignment, if you have any request, you send me an email. AO, collectively, you can send me an email, and we'll discuss about that. Okay?
Okay.
Yeah. And always try to be within the time frame. But you send the request. Okay? You.
Okay, Chief, I will send the
Yeah.
request.
Any other question? Mela say, yeah, you wanted to say something. Yeah, tell me.
Chief, some of the slides
Yeah.
they are not in the the
Yeah,
book.
I'll,
I mean
yeah,
the
yeah,
handouts. Can you please send us by email?
yeah, I'll
Thank you.
send. Like the other portion, some I give you, this also I'll give you. Okay, I'll send you by
Okay,
email.
thank you.
Yeah. So, any other questions? If there is no question, then we can close it for. Okay, one day you want to say something? Tell me.
Again about the assignment.
Yeah,
Assignment
tell me.
number 4 about the refrigeration,
Yeah,
thermostatic valve and oil separators. The
yeah.
two questions are coming, the same question again coming A and B. Both are almost the same. Yeah.
Almost
Can
the
you check?
same you said, but almost and exactly the same. They were two different, isn't it? Understood. So
No.
yeah.
Uh,
So it is in different way. It is been asked.
the thermostatic failures due to the oil separation.
Let's see
Can you
what you want to this. You send me an email, but it will be only clearing your doubt about the question. I can answer. I cannot answer. I'll discuss only after you submit. You all submit your assignment. After that, I will discuss the answer.
Okay, please check assignment number 8 about the thermo A and B.
Yeah.
Looks like
So okay. That is the thermostatic expansion valve and the oil separator. I'll check. Okay.
just check it.
And I'll send you an email about the question. Yeah. And Asefa, tell me. Asefa.
Chief,
Yeah, tell me.
about the number of the words. If we, for number 8, when I'm working, the words are more than 1,200 words.
Yeah.
It is difficult.
No problem. That is. Asefa, that is not a problem.
All right.
Okay.
Yes, Chief, understood.
Yeah. So any other question? If no question, then we close it for lunch, and next session will be at 1400 hours. Okay.
Okay, Chief. Thank you very much.
Thank you, Chief.
Thank you, sir. Thank you.